Good day to all of you. Today we shall study kmap method, Karnaugh map method. So what is that? Kmap method, it's a very simple and straightforward method used to simplify boolean functions. Boolean functions means the equations which have the variables having only two values, either logic 0 or logic 1. Kmap is a pictorial form of truth table. So in that first we shall consider two variable kmap. This kmap is used to simplify boolean function having two variables. Let the two variables be x and y. The new term that we have to know is min term. It is represented by small letter m. The variables in boolean equation can have only two values, either 0 or logic 1. For any two variable boolean function, there can be four combinations of input variables. So x and y are called as input variables here, right? So both may be logic 0, both may be logic 1, or x may be 0, y may be 1. In another combination, input variable x may be logic 1 and y may be logic 0. Hence, to the maximum 1, 2, 3, 4, four different combinations are there in a boolean function of two variables. Then what is min term here? So four combinations means four min terms we can have. Min term is represented by small m. So min term 0, m0, m1, m2, m3. So what are these? m0 means here both the variables will be 0, and when x is 0, it is represented as x dash. When y is 0, it is represented as y dash. For x0, y0, x is 0 and y is 0. Hence x dash, this is AND operator. This dot operator is called as AND operation, logical AND operation. Hence x dash and y dash indicates that x is 0 and y is also 0. This is called as min term 0, m0. So m0 means x dash and y dash, or we read it as x dash y dash. Similarly, in next combination, x is 0, y is 1. So x is 0 means x dash and y is 1 means it is written as simply x dash y. That is x0, y1. This is written as min term 1, m1. Similarly, we have m2, min term 2. That is x is 1 and y is 0. X and y dash, x, y dash. X is 1, y is 0. This dash indicates y is 0 here. Next, last one is min term 3, m3. M3 means both input variables x and y are logic 1. So, x and y. X is 1 and y is also 1. So these are the four possible min terms in a boolean function of two variables. And this is also called as product term. Min term is also called as product term. So for a two variable boolean function, we have four min terms starting from m0, then m1, m2, m3. m0 to m3. Next, the actual kmap for two variable boolean function, how it is written. So this is one form of writing, this is another form of writing. So for two variable boolean function, 2 raised to 2, 4 squares have to be drawn. 1, 2, 3, 4. Then the two variables are listed here. This is one variable x, another variable y. In the problem, whatever variable is given, that we have to take here. Suppose if it is a and b are there, a here, b here. Next, for x, so x dash may be there or x may be there. That is, x may be take 0 value or 1 value. Similarly, y variable can be y dash or y. Y may take the value 0 or 1. So with values, when we write this kmap for two variable, this is another form we'll get. That is, two variables are listed here, x, y. X may be 0, x may be 1, or y may be 0 or y may be 1. Writing x as x dash or 0, both are one and the same. In this, x is written as x, here x is written as 1. So both are the k-maps for two variable boolean function. Both are one and the same. Writing is different. That's all. So here we can list m0 means minterm 0, that is x dash and y dash. m1 means minterm 1, x dash and y. m2 means minterm 2, that is x and y dash. Last one, m3 means x and y. Both the values will be 1 here, here 1 0, here 0 0, here 0 1. Right? So first, before trying to solve any two variable boolean function, we must learn how to write corresponding k-maps for the two variable boolean function. Next, we shall see an example for simplification of two variable boolean function using kmap. So example given is simplify boolean function. So this is one form of asking the question. Or they may give truth table like this, where x and y are the inputs, f is the output. The four combinations, 1, 2, 3, 4 combinations for two variables are written here, and for each combination what is the value of output, that is f, that is filled here. So we have to simplify the boolean function f whose truth table is as above. This is second form of asking the same question. Why it is same here? F given function is m1 or, this is logical or operator, m2 or m3. Means for this minterm 1 or 2 or 3, the output f is true, logic 1. Hence, if you draw the truth table for this function, it is this way. So the maximum number is 3 here. So it can be expressed using 2 bits. Hence, we take two variables here and we name them as x and y. Right? Using a and b also we can name them, but here we have taken x and y as the two input variables. All the four combinations are listed. F is the given function. Where all f is 1 for m1 or m2 or m3. So this is m1, m2 or m3. So f is 1, 1 and 1 here. F is 0, that is minterm 0, m0. Right? It is not included in the given logic function. Simplify this function or simplify the function given in truth table. Both are one and the same. Both the problems are one and the same. One more form of asking is there, or one more form of expressing or asking the same problem. So or simplify f equal to x dash y, or this is logical or xy dash or xy. So x dash y 0, x is 0, y is 1, 0 1 means this is m1. This is 1 0, this is m2, 1 1. So this is m3. So instead of asking f equal to here m1 or m2 or m3, using the input literals they have written here. So simplification of this function and simplification of boolean function given in the truth table or simplification of the given function f, all are one and the same, just way of asking or expressing is different. Now we shall solve this using kmap. Because two input variables are there, we'll have to draw 4 squares. which we have already learnt just now. So we'll mark the input variables x, y here, right? So x can be 0 or 1, y can be 0 or 1. Where all f is true or logic 1, it is true for m1. This is m0 place, this is m1 place, m2 place, m3 place. So when we fill the function x, y, 0, 1, 0, 1, m0 is not there in the given function, means it is 0, already we have filled. So when x 0, y 0. When x 0, in this row x 0, y 0, this column which is m0, there it is 0. This is place for m1. This is m1, f value is 1. Then m2, f value, this is m2 place, f value is 1. This is m3. So when filled kmap for f, we'll get this way. Okay. The first thing is what expression is given or boolean function or truth table or this, whatever be the form of asking, we'll have to identify in the given function which minterms are there. For that, we'll have to fill the value 1, which are not there, that is 0. So one step is over. For the given boolean function, we have filled the kmap. Next, we'll have to group ones, right? So group ones means here 1, 2, 3 ones are there. We must take so many groups, as many are required to cover all ones. And whatever group we draw here, it should be of rectangle or square size. It cannot be diagonal like this. This and this we cannot group like this because the shape of diagram will be diagonal one. We can group these two. These are adjacent ones. So we'll group this. One group is formed. How many ones are covered here? 1, 2. So this is remaining. This also we must try to cover. Always we must try to draw the biggest group. Biggest means 1, 2, 3, 4 squares are there. All the 4 do we have ones? No. Hence a group of 4 or quad cannot be made here. Then we have to go for a group of 2. In that sense we have drawn this. The shape being either rectangle or square. This diagonal we cannot do. So this is a group 1. With this one group, only 2 ones are covered. One more is remaining. To cover this quad we cannot draw. This diagonal we cannot draw. But this is another adjacent. So this is second group. Now we have to stop drawing groups because we have covered all the 3 ones. So the minimum number of groups we should draw and we should try to cover all the ones. First we draw one group. This was remaining. So then we have drawn another group. With 2 groups, all the 3 ones are covered. Next we have to stop drawing groups. Now how many groups are made? 1, 2. Hence in the solution 2 product terms will be there. So simplified solution will be one term or another term. This with respect to first group will write. This with respect to second group will write. First consider this group. 2 ones are there in this group. For these 2 ones, row wise what is common, column wise what is common, we have to write. So these 2 ones fall in this row. Row wise this 1 is common, that belongs to x. Hence x is common, we write it. And for the first group, column wise what is common? These 2 ones fall in this column, in this column. So column wise nothing is common, just leave it as it is or write 1. Okay. Next consider this second group. There are 2 ones. This one falls in this row. This one falls in this row. Then in these 2 rows, these are covered. So we have to compare these 2 rows. Row wise nothing is common. Okay. So we'll simply write 1 and. Next, column wise, these two ones fall in same column. Then what is common here? 1 is common for both, which belongs to y. This belongs to y. Okay, so y. Hence, the final solution is here x, this is or, this is y. So this is the simplified solution for the given problem. Okay. Now to revise, two groups we had made of rectangular shape. Diagonal shape is not allowed. Either square or rectangles can be drawn. So one group when we had drawn, two ones were covered. To cover this third one more rectangular shape group we had drawn. Now one group is formed, second group is formed. Hence there will be two terms. Then for each group we'll have to consider what is row wise common and column wise is common. So for group 1 we write the terms here. What row wise common? So for these two ones in this group, this is one which belongs to x, hence x we have written. If you write this or no, it's okay. What is there in the first group? X. Or in second group, y. Which is second group? This one. This is second group. So here row wise nothing is common. You may write this one or no. Then column wise what is common? This one is common which belongs to y. Hence y we have written. So f equal to x and with 1 means x only, 1 and with y means y only. So you may write these two yes or no. So we get x or with y. So f equal to x or with y is the simplified solution for f equal to m1 or m2 or m3, or this table where f equal to 0, this is for m0, for m1, m2, m3 it is 1, or simplify f equal to x dash y or xy dash or xy. So for all this is the solution. What is the final solution here? F equal to x or with y. Okay. So what was the topic? Kmap method. In that for two variable boolean function to simplify, two variable kmap is used. In that we solved one problem. That completes the discussion. I hope you understood. Thank you.